Understanding Super El Niño, Formation, Timeline, and U.S. Meteorological Impacts. To completely understand the birth, progression, and widespread devastation of a Super El Niño, it is essential to first examine the massive atmospheric and oceanic engine that governs the Pacific Ocean under normal conditions. The Pacific Ocean is an immense body of water that covers more than 1/3 of the entire surface of the planet. Because of its sheer size, the interactions occurring across its equatorial belt serve as the primary engine for the global climate system. Under standard, non-El Niño conditions, this planetary engine is kept in a state of stable equilibrium by a continuous atmospheric convection loop, known to meteorologists as the Walker circulation. The Walker circulation is entirely driven by an intense contrast in barometric pressure across the equator. Under standard settings, a semi-permanent high-pressure weather system sits securely over the cold waters of the eastern Pacific Ocean, specifically along the coastlines of South America near Peru and Ecuador. Conversely, a permanent, deep low-pressure system hovers over the naturally warmer waters of the western Pacific, blanketing the regions of Southeast Asia, Indonesia, and northern Australia. Because atmospheric air naturally flows from areas of high barometric pressure to areas of low barometric pressure, this permanent pressure gradient creates a relentless, powerful highway of surface winds known as the equatorial trade winds. These trade winds blow continuously from east to west along the equator, acting as a giant invisible planetary broom that sweeps across thousands of miles of open ocean surface year after year. As these trade winds travel westward along the equator, they drag the top layer of ocean water along with them. Because this specific layer of surface water is sitting directly under the intense, direct rays of the equatorial sun, it acts like a solar collector, absorbing an immense amount of thermal energy and becoming incredibly hot. By the time the trade winds push this water across the vast expanse of the open Pacific, it physically piles up in a literal, mounded reservoir of hot water in the west. This vast geographical feature is known to meteorologists as the Western Pacific Warm Pool. The warm pool is not just a localized, shallow patch of warm water. It is a massive storehouse of oceanic heat that measures several degrees warmer than the rest of the Pacific and extends hundreds of feet down into the sea. Because hot water naturally heats the air directly above it, this warm pool causes the Western Pacific atmosphere to become highly unstable, filled with moisture and buoyant. This warm, wet air rapidly ascends miles into the sky, cooling as it rises, which leads to massive condensation, heavy cloud formation, and predictable heavy tropical rainfall that sustains the agricultural systems and lush rainforests of Southeast Asia and northern Australia. After releasing its moisture, this dried air travels eastward high in the upper levels of the troposphere, eventually sinking back down over the cooler eastern Pacific, completing the Walker circulation loop. While this massive accumulation of heat is taking place in the west, a completely opposite, vital oceanic process is simultaneously triggered on the eastern side of the ocean near South America. Because the trade winds are continuously dragging the warm surface water away from the coasts of Peru and Ecuador, they leave behind a massive physical vacuum on the ocean surface. To fill this empty space, a monumental vertical ocean current is activated. Cold, dense water from the dark, deep ocean is pulled upward to the surface in a process known as upwelling. This deep water is packed with a dense concentration of nitrates, phosphates, and decayed organic matter that has settled on the seabed over centuries. When this nutrient-rich water reaches the sunlit surface, it acts as a massive fertilizer, fueling the growth of marine ecosystems and keeping coastal South America cool and dry. This delicate equilibrium between western warmth and eastern cold is the baseline settings for the world's climate, keeping global storm tracks and seasonal transitions completely predictable year after year. The transition from this stable global climate baseline into the chaotic state of a Super El Niño begins when this entire barometric pressure engine undergoes a radical, unexpected, and catastrophic breakdown. This atmospheric breakdown is officially known as the Southern Oscillation, and when combined with the oceanic changes, it is referred to by scientists as ENSO, or the El Niño Southern Oscillation, for reasons that are deeply tied to complex ocean atmosphere feedback loops. The high-pressure system over the eastern Pacific suddenly collapses and plummets, while the barometric pressure over the western Pacific spikes dramatically. This sudden flattening of the pressure gradient completely destroys the atmospheric highway that drives the global weather engine. Because the pressure difference between the east and the west has vanished, the steady, dependable trade winds begin to falter and slow down. In the case of a true Super El Niño, these winds do not just weaken, they stall out entirely, or completely reverse direction, blowing violently from west to east backward across the equator. The moment the trade winds collapse or reverse, the structural dam holding back the western Pacific warm pool is completely removed. Without the constant pressure of the winds to pin it down near Asia, that massive towering mountain of hot water is set loose. It sloshes backward across the entire length of the Pacific Ocean toward the Americas. This movement does not happen overnight. Instead, the thermal energy travels eastward along the equator in a series of deep subterranean ocean waves called equatorial Kelvin waves. These Kelvin waves travel roughly 1 to 200 feet beneath the surface, moving at a speed of several miles per hour, carrying a colossal volume of displaced heat energy across thousands of miles of open sea. As these Kelvin waves march eastward and collide with the coast of South America, they act like a thick, suffocating hydraulic blanket. They plunge the thermocline, the sharp boundary layer that separates the warm surface water from the freezing, deep ocean water, hundreds of feet downward into the sea. With the thermocline pushed deep into the ocean, the vital vertical process of cold water upwelling is completely choked off and disabled. The deep ocean currents still try to pump water upward to fill the coastal currents, but instead of drawing cold, nutrient-rich water from the deep sea, they can only circulate the thick, suffocating layer of hot water that has sloshed over from the west. Within a matter of weeks, sea surface temperatures across the central and eastern Pacific skyrocket by 3 to 5 degrees Celsius above historical averages. This massive, unnatural temperature spike covers an area of the ocean larger than the continental United States. The ocean surface off the coast of South America transforms from a chilly, life-giving ecosystem into an erratic, overheated thermal reservoir. This immense pool of misplaced heat energy completely breaks the global climate anchor, initializing a Super El Niño and beginning a massive chain reaction that will fundamentally alter the thermodynamics of the entire global atmosphere. Once the warm water completely blankets the central and eastern Pacific Ocean, it immediately begins to exert massive atmospheric forcing on the rest of the planet. Because the Pacific is the largest ocean on Earth, changing its surface temperature is equivalent to turning on a giant, unyielding thermal heating pad right in the middle of the globe. This newly misplaced ocean heat pumps an unprecedented amount of thermal energy and evaporated moisture directly into the upper troposphere. As this massive column of hot, wet air rises over the eastern Pacific, it creates a powerful physical barrier in the upper atmosphere. This barrier permanently alters the path of the jet streams, which are the high-altitude rivers of fast-moving wind that act as the primary highways steering weather systems, storms, and air masses across the globe. Under normal conditions, the polar jet stream and the subtropical jet stream guide storms in a balanced path. However, the immense thermal energy rising from a Super El Niño violently disrupts this flow, forcing the polar jet stream to retreat far to the north into northern Canada, while the subtropical jet stream splits, drops lower in latitude, and intensifies into an atmospheric powerhouse. A Super El Niño is never a sudden, fleeting storm system that passes over a weekend. It is a prolonged, deeply entrenched climatic cycle that operates on a distinct chronological timeline. The very first warning signs of an approaching anomaly typically begin to manifest during the late spring months as satellite data and deep ocean buoys detect the initial drop in barometric pressure and the early formation of equatorial Kelvin waves. Throughout the summer months, the event steadily gains strength as ocean temperatures continue to climb across the equator. The phenomenon reaches its absolute maximum, mature intensity during the winter months. This winter peak is actually how the event earned its name. Spanish fishermen in South America noticed the sudden warming of the ocean and the disappearance of fish always occurred around December, leading them to name the phenomenon El Niño, which translates to the boy child in reference to the Christmas season. While a standard minor El Niño might linger for 9 to 12 months, a true Super El Niño possesses such a staggering amount of residual thermal energy trapped in the upper ocean layers that it locks the global atmosphere into a state of severe disruption for up to 18 to 24 consecutive months, completely exhausting the planet's heat supply before the system can naturally reset and clear. When a Super El Niño enters its peak, mature winter phase, the meteorological expectations for the United States become incredibly stark, severe, and geographically polarized. The primary driving force behind the weather across the United States during this time is the supercharged subtropical jet stream. Because this high-altitude river of wind has been dragged low and packed with intense energy from the warm Pacific, it creates an unyielding atmospheric conveyor belt that carries low-pressure systems and tropical moisture directly into the North American continent. This setup splits the United States into two entirely different worlds of extreme weather anomalies, forcing different regions of the country to deal with either unprecedented moisture surplus or catastrophic moisture scarcity. Across the southern tier of the United States, a vast region stretching from Southern California, moving through the desert southwest of Arizona and New Mexico, cutting directly across the state of Texas, and extending into the Gulf Coast and Florida. The weather becomes unseasonably cool, exceptionally damp, and highly volatile. Southern California bears the initial, violent brunt of this supercharged atmospheric highway. The region is repeatedly bombarded by a series of successive atmospheric rivers. These atmospheric rivers are long, narrow plumes of dense, concentrated moisture vapor that stretch all the way from the tropics to the west coast, often referred to colloquially as the Pineapple Express. When these atmospheric rivers collide with the mountainous terrain of California, they are forced upward, causing them to release catastrophic amounts of rainfall over incredibly short periods. This unrelenting moisture quickly saturates the soil, leading to widespread flash flooding, overflowing river basins, and massive, destructive mudslides that tear down hillsides, wash away coastal highways, and threaten critical infrastructure. As this supercharged subtropical jet stream continues its journey eastward across the country, it brings the same volatile, moisture-heavy conditions to Texas and the Gulf Coast states. These regions face repetitive, multi-day rain events that dump historic amounts of water, completely overwhelming local drainage systems and flooding agricultural fields. Because the jet stream brings a constant clash between cool air masses from the north and highly energized, warm, moist air from the Gulf of Mexico, the southern states also experience a dramatic spike in severe winter weather outbreaks. This includes unusual winter thunderstorm lines and localized tornado outbreaks fueled by the highly active wind shears created by the displaced jet stream. For months on end, residents across the American South must adapt to a climate that is vastly wetter, stormier, and more hazardous than anything they experience during a normal winter baseline setup. While the southern United States is being inundated by historic rainfall and flooding, the northern half of the country experiences an entirely opposite meteorological crisis, characterized by severe deficit and unseasonable warmth. Because the polar jet stream has been pushed and pinned far to the north into northern Canada by the rising heat of the Pacific, it acts as a powerful atmospheric wall. This wall effectively traps the freezing Arctic air masses up in the polar regions, preventing them from dipping south into the United States. Consequently, a vast swath of the nation, including the Pacific Northwest states of Washington, Oregon, and Idaho, the northern Rocky Mountains, the Great Plains, the Midwest, and parts of New England, finds itself trapped under a persistent high-pressure ridge that brings unseasonably warm, mild, and incredibly dry conditions. This northern deficit has immediate and devastating consequences for the environment and regional water supplies. In the Pacific Northwest and the northern Rockies, winter precipitation is absolutely critical because it builds up the mountain snowpack. This snowpack acts as a natural, slow-releasing water reservoir that sustains the region throughout the rest of the year. During a Super El Niño, because temperatures are unseasonably high, the precipitation that does fall arrives as rain rather than snow, and the overall volume of moisture drops significantly. Ski resorts are left with barren, muddy slopes, causing severe economic losses for winter tourism. Far more critically, the mountain snowpacks fail to develop. This lack of frozen storage guarantees a dangerous domino effect for the following spring and summer. Without a melting snowpack to gradually feed rivers and streams, water reservoirs drop to critically low levels, threatening municipal water supplies, halting hydroelectric power generation, and devastating native fish populations, such as salmon, that require cold, fast-flowing water to survive. Furthermore, this prolonged lack of winter moisture leaves the vast northern forests completely parched. Without a protective layer of winter snow to insulate the ground and keep the soil damp, forest floors dry out months ahead of schedule. By the time spring arrives, the vegetation is already brittle and highly flammable, dramatically shifting the regional wildfire season forward and increasing the frequency and intensity of catastrophic forest fires. The impacts of a Super El Niño eventually ripple outward from regional weather forecasts into the daily economic realities of every American citizen. The severe droughts in the north and the intense flooding in the south destroy agricultural crop yields, causing a sharp spike in grocery prices across the nation. Heating bills may drop in Chicago due to the unseasonably mild winter, but property insurance rates skyrocket in Los Angeles and Houston to cover the billions of dollars in structural damage caused by mudslides and floods. Furthermore, the total disruption of marine upwelling off the coast of South America disrupts global fish meal markets, altering livestock feed prices and multiplying the financial shockwaves throughout the global food supply chain. Energy grids are forced into extreme stress. While northern states see decreased winter heating demands, southern states experience surges in power infrastructure strain due to extreme storm responses and unpredictable temperature fluctuations. Water management districts across the West Coast are forced into a delicate, dangerous balancing act, trying to prevent immediate reservoir overflows from flash floods, while desperately trying to conserve enough volume to combat the looming summer drought caused by the missing northern snowpacks. Transportation corridors suffer immense disruptions as major rail lines and interstate highways across the Southwest are frequently washed away or blocked by debris fields, creating logistical logjams that delay shipping and trade from coast to coast. Human health risks also escalate as shifting moisture patterns alter vector-borne disease habitats, leading to spikes in regional pest populations and increased transmission windows for respiratory issues driven by massive wildfire smoke plumes in the succeeding summer months. Ultimately, a Super El Niño is the definitive demonstration of planetary interconnectedness, proving that a single profound barometric pressure collapse over the remote equatorial waters of the Pacific Ocean can completely right the seasonal rules, environmental baselines, economic infrastructures, and daily operations of modern human civilization. Ultimately, the life cycle of a Super El Niño serves as a stark reminder of the absolute precision governing our planetary mechanics. A simple breakdown in equatorial pressure gradients does not just fade away in the open ocean. It acts as a catalytic event that triggers a radical, thousands of miles wide atmospheric reorganization. For the United States, this dynamic forces communities to adapt to dramatic shifts in seasonal extremes, turning normal environmental predictability into a complex grid of flood management, reservoir deficits, and altered agricultural baselines. Because the thermal energy trapped within the Pacific during these massive events takes up to 2 years to fully clear and dissipate. Understanding the science behind the formation and trajectory of a Super El Niño remains one of our most critical tools for modern meteorological forecasting and civilian readiness. If you want to understand how our global climate system can completely rewrite seasonal rules overnight, make sure to like this video and subscribe to the channel for more in-depth breakdowns of major planetary weather systems. Leave a comment below letting us know what kind of unseasonable winter patterns you have been experiencing in your part of the country. And don't forget to hit the notification bell so you never miss our latest scientific analyses.